An integrating factor of the differential equation dy over dx is equal to 2xy square plus y upon x minus 2y cube. This is the differential equation and we have to find the integrating factor. So first understand what is the integrating factor or its meaning. Integrating factor is the function of xy which make the differential equation uh, as a exact linear differential equation. So as we have to find integrating factor, so we can understand this given differential equation is not exact. Means if you find to check the condition of exactness, which is partial m with respect to y, which one not equal to partial n with respect to x. So this condition is true for this. If it will be the exact, then equality hold in partial derivatives of m in n as I wrote. So you can see partial derivative of m in n. So this is not exact differential equation. Now to make this differential equation exact, we have to multiply some function of xy. Suppose x raised to the power alpha and y raised to the power is the integrating factor for this differential equation. But as you can see, options a, b, c and d, so x is not involved here. It means you can directly say that value of alpha is 0, but we have to find the value of beta. So consider this one, and this integrating factor makes the differential equation exact. So now we have to find what is the new m and n. So m1 will be 2x raised to the power because of m dx. So 2x raised to the power alpha plus 1 y raised to the power beta plus 2 plus x raised to the power alpha y raised to the power beta plus 1. This is the value of m1, and this is the value of n1 will be minus x raised to the power alpha plus 1 and y raised to the power beta plus 2 raised to the power alpha y raised to the power beta plus 3. Now check, because this is the integrating factor, and now this makes differential equation exact. So we have to put this condition: partial m1 with respect to y is equal to partial n1 with respect to x. This condition is true. So now we have to find partial derivative of m1 and n1. So it will give you 2 beta plus 2 x raised to the power alpha plus 1 and y raised to the power beta plus 1. 1 power less plus x raised to the power alpha. So this is beta plus 1 x raised to the power alpha and y raised to the power beta is equal to minus of alpha plus 1 x raised to the power alpha y raised to the power beta plus 2 alpha x raised to the power alpha minus 1 and y raised to the power beta plus 3. So this condition, this term is having x raised to the power alpha and y raised to the power beta. Also this one, this one and this one. So we take x raised to the power alpha beta as a common, or we can divide this equation throughout. So we obtain after dividing, so this one equal to 2 times beta plus 2, and x raised to the power alpha is divided, so xy plus beta plus 1 is equal to minus of alpha plus 1 plus 2 times alpha, and it will be x minus x raised to the power minus 1 and y raised to the power 3. So we obtained this expression. So you can compare coefficients. So this is constant terms. So on comparing constant terms, so beta plus 1 is equal to minus alpha plus 1. This implies alpha plus beta is equal to minus alpha this one is like this, so minus 2. And we know that as options, if alpha equal to 0, this implies that beta equal to minus 2. So we have the value of beta now, means as we consider x raised to the power alpha and y raised to the power beta is the integrating factor, value of alpha is 0, so integrating factor will be 1 upon y square. So finally we have the solution. Otherwise you can compare the coefficient of xy. This implies that 2 beta plus 2 is equal to 0. Also this one is giving you beta is equal to minus 2. Otherwise you can compare coefficient of x raised to the power minus 1 and y raised to the power 3. This one will give you as value of alpha is 0. Now put the value of in this one and you can find the value of beta. So we have option B is the correct answer.